Good afternoon, good evening, good morning. Thanks a lot for joining us today. We're here live together with Itai from US, Dave from UK, and Philip and myself from Germany. I see that people are still coming in, so I will take a few minutes just to welcome you. I'm very happy and pleased with the incredible response from the community. We had more than 350 registration. So this is really nice. It's also a clear indication that collaboration and working together is also leading to the right results. We will start with a brief introduction. So I'm sharing this virtual room together with Dave, Itai. So I will start to introduce myself. My name is Valerio. I'm working as a senior business developer manager at IGI. I've been with the company for 2 years and I enjoy supporting our clients in selecting the right sensor constellation. I enjoy supporting them in the projects, and that's all about me. So Philip, if you want to say a few words, and then we will have a round table of introduction, each one of us.
Yes, thank you, Valerio. Thanks, everyone. Hi, everyone. Thanks for joining us today. So this is a great start into our webinar series for 2022. I'm very happy to have Dave and Itai here with us. And I think we have a great program for you. For a lot of you who don't know me, I'm one of the general managers of IGI. And please, Dave, I take over the microphone to you.
Okay, thanks, Philip. Yeah, welcome everyone. I'm Dave Horner. I'm the CEO of Get Mapping. I'm a 30-year veteran of geospatial industry. I've been with Get Mapping in various guises since its inception in 1999. But over the last 12 months, really been getting excited by what we're seeing in the geospatial industry and in starting to help our customers and our partners leverage the power of geospatial. So really excited by the webinar today because I think it's one of the initiatives we're doing to really help our customers do a lot more with geospatial data.
Thanks, Dave. I'm Itai Schechter with Skyline Software Systems, and I manage our imaging partnerships with different imaging providers such as IGI and a lot of our 3D products and PhotoMesh 3D reconstruction tools. We've been working with IGI and Get Mapping, like the Dave and Valerio mentioned. Looking forward to sharing the results from this data set and some of the things we've done.
Yeah, thanks a lot. Thanks a lot also for introducing yourself. So this is a live session, meaning we're not using any video recording. So you have the opportunity to see with Itai the live demo, in-depth technical demo of the City of London in 3D. So it's going to be an educational session about 2D and 3D production. So stay until the very end. And with Dave, we will also learn more about how high resolution data is also changing the way in supporting their clients. And from my side, I will start now with the presentation. So I will have a brief introduction about IGI, and I will help you also to fly to London, which is the area of interest of this project. So the imagery were collected with the IGI Pentadigicam. The GSD is 3 centimeters. As you can see, I've been selecting an area of the Shard. It's one of the most representative building in the city, but I would say also in Europe. It's a 72-story skyscraper designed by the Italian architect Renzo Piano. It's really nice to see that if you think about this complex urban setting, there are a lot of glass. It's also challenging lighting condition, but the image is coming out very nice and crispy and very sharp. So one of the focus that Dave will take over in his presentation is high resolution data. And you can see here that you can zoom in down to 100%. And you clearly have the full details of the scene. So you can see people walking, the identification number of the bus. So really high resolution below 5 centimeters is really providing a depth and breadth of intelligence that you can extract and also use in the production of true ortho and mesh. So I will provide a brief overview about IGI. I will be focusing only on the airborne vertical, so our aerial mapping camera system, a LiDAR system. But first of all, I want to bring you on why IGI. So we are combining cutting edge technology together with innovation. And what we like to say is to create a win-win situation for our clients. So we really put our clients first. We focus on reliability and efficiency in our sensor technology, but also ensuring best return on investment to our clients and first-class technical support. Another topic is also that we are not involved in any data content program, but we really stay focused on sensor development and manufacturing. So we are proud to say that we are the only vendor offering end-to-end system. In particular, we do in-house development and manufacturing. If you focus on the IMU and CCNS, our IMU are from 1996, so the first series were introduced to the market. They are becoming the industry standard for positioning and flight guidance. And I will also show to you a little bit more about our aerial camera system, light mapper system, and also integration of thermal, hyperspectral, and SAR. Thanks to this very unique set of expertise, we're also able to work with very special projects like the Open Skies. As you see, is operated by the Bundeswehr, which is the German armed force. Here you have just an impression of the IGVISU, so we work also on the software part. And here is just an overview of how the camera has been installed into this aircraft. It's one of the largest aircraft that IGI has been equipping. So it's very special project. So it's also showing our modularity and very unique design. So our modular design is also helping in lowering operating costs and also ensuring the right flexibility and easy aircraft installation. Just an overview of the IGVISU, the operator point of view. So you have full control of the imagery that have been captured. You have full QC also while flying in real time. And this is just to give you an overview of our portfolio. So you can go from medium format, large format, 2-in-1, and integrated system. So we can also do integrated system like the Urban Mapper 2P together with the large scanner like the 1560. Just to say that our clients have been collecting near-infrared imagery since many years, so focusing also on high resolution, as you can see in this image, and of course also blinking high resolution. So we really stay focused on high resolution data, but of course we have also client flying with 10 or 15 centimeter GSDs, really up to the client what sort of GSD to target. I will round up a little bit on the airborne domain. So what you can see directly here is the IGI Digicam 450. This is our large format camera. So it's basically the nadir part of the Urban Mapper. You have different lens constellation. Same applies with our Penta Digicam. This is similar concept of the camera that has been used through the project in London, which will be presented by Dave Eitai. As you can see, you have a lot of lens constellation, so we really provide a lot of flexibility to our clients. This is a new system which we are offering. We already sold a unit. Is the IGI Penta Digicam 280, so you have a larger native footprint. So the difference between this Penta and the previous Penta is that here you have a larger native 280 megapixel. Before was a system with 5 camera head, so only 150 megapixel in the nadir. Near infrared is coming as a standard, and the current constellation is with 90 and 110 millimeter. I will move now to the flagship. So our product flagship is the Urban Mapper 2P, and the news is that on top of the current constellation, starting from 90 millimeter, 110, 180 millimeter for nadir and oblique constellation, we have the new 180. So the 180 millimeter is something new that we are offering, and is in particular for high altitude flight. An overview about the GSD that you can target. So if we just stay in the middle, 150 millimeter in the nadir, flying from 2000 meter, you will capture a GSD of 5 centimeter. It's a very compact presentation from my side, so please make sure to ask your question if you would like to know more about us, also about the project. Feel free to write in the chat, because there will be myself, Philip, Ida, and Dave also taking care. And now I want to show you a little bit about our light mapper system. So we have capability also to integrate a large scanner like 780, 1560. We did this in the past, and this is how it looks inside. So it's the particular like red box light mapper. Then you have the IMU 3-camera system, but we can also work with hyperspectral system. Before giving the word to Dave, I want to show you some installation. So installation into a Tecnam of the IGI Digicam 450 together with the Lightmapper 580. The similar constellation was used, same aircraft was used also for the project in London. The only difference, it was done with the IGI Penta Digicam. So installation into the Diamond, the A62. You can see the Lightmapper 780 with our IMU. You also have possibility to have the Urban Mapper as you have two hatches. This is the installation for our client AeroWest IGI Urban Mapper 2P. Installation into the large Tecnam aircraft where you have two hatches, so you have flexibility to have a large format camera like the Urban Mapper 2P together with the Lightmapper 780 or 1560. So there is of course a lot of space. Some installation as well in the Antonov in Russia of the IGI Urban Mapper 2P. You can see that for the operator point of view, you have the CCNS5 together with a large screen. So it has completely full control of what the camera is capturing and also is able to perform QC directly in real time. Installation of the IGI Digicam 100 and the Lightmapper 1560. You can see that the scanner is really large and is also coming together with the Digicam 100. Now, what we like to say is really providing our clients with leading edge camera systems so that they can really capture sharp imagery in high resolution, which is the main focus of this webinar. And as you can see here, you have a very nice image, so brilliant. You can even zoom in a little bit more, and Dave will also present a little bit more details and zoom in the project. It's really difficult then when you go from imagery also to mesh. So we have enjoying also working closely with Skyline, and you can see already when you go from mesh to imagery, it's really nice to see, and you get really high quality products, 2D and 3D products. So through ortho, classical ortho, and we will see this directly together with Itai during the session. So that's all from my side. I want to connect with Dave's presentation now. And this is just an overview of the mission that was done in London. It was done again, just as a reminder, with the Penta Digicam together with the Lightmapper 5800 VQ from IGI. So full system setup from us. And it's a real pleasure for me now to go to Dave's presentation. And yes, I think, Dave, you can just take over by starting sharing from the screen, and then it will automatically go to your slides. Okay, I can see the slides. It's all good. Just your microphone, I think you're muted.
Sorry about that. Schoolboy error there. Do apologise, everyone. Thanks, Valerio. Just to briefly introduce Get Mapping to those of you on this webinar who might not know us already, we are a geospatial data and solutions company. And as I said in the introduction, really our specialism now is around helping people to leverage the power of geospatial data into your organizations. And I think with the technology that you're seeing from IGI in terms of changing the way we can capture and the level of detail we can capture to in this set of data, that in turn is changing the sort of conversations we're having with customers and partners and what we can do with the data. So it's why I think this is, to me, the most exciting time in geospatial that I can recall in 30 years, because we're coming from being a niche industry into the mainstream because the data can do so much more. Just to give a little background to Get Mapping before I get onto that. We've always had innovation at our heart. We've been around for 23 years now. We started life as the first company doing a commercial national imagery survey off the shelf for the whole of Great Britain back in 1999. And back then it was 25cm resolution with a film camera, but we were very early adopters of digital camera technology, and we've been working with IGI since the early noughties and using their technology to allow us to drive forward significant step changes in the quality of data. And I think the advent of digital and the size of the cameras we now get has moved us to surveying the country at 12.5cm resolution on a 3-year update now. And with the new data we're showcasing today, mapping our cities in an incredible level of detail. It really is, I think, a game-changing level of detail, which I'll show in a moment. We're also early adopters of a web shop and WMS mapping services and platform services. So platform delivery has always been the heart of what we do, and I think in this current age that's hugely relevant as well. But I'm going to jump forward a few years, not go through every step in the innovation life of Get Mapping because we've only got 15 minutes. But in 2017 we added mobile mapping to our capabilities, and that's now allowed us to offer a full ground up and air down service. And that's relevant because increasingly today our customers are trying to map the built environment digitally and creating digital twins and reality capture of the built environment. And the technology that Valerio was showcasing and the technology that Itai will showcase with Skyline is really now enabling that to happen for our customers in 3D. And the data we're showing today can be used to an incredible level of detail in both 2D and 3D. That's led us to the launch of our platform, GSAS, which I'll talk about in a second because it's relevant to this project. But before I do that, I just want to give you a little bit of insight into the background to the launch of our platform, really, and what we're seeing happening around us now. As you're probably aware, we're in the middle of this fourth industrial revolution, the so-called technology revolution, driven by key enablers such as 5G and artificial intelligence. What that's leading, I think, the geospatial industry to start to think and start to say and recognise is that geospatial data fuels that revolution. It's embedded intrinsically in things like autonomous vehicle solutions, smart cities, for example, digital twins. But we're actually going further because we believe now that geospatial data needs to start being recognised as a key enabler. So as an organisation out there, if you have a digital transformation strategy and you have anything to do or need for locational information, then the question would be, what's your geospatial strategy within that digital transformation? And the reason for that, I think, is with the data we're showcasing today, geospatial data can now do so much more, and it is now a key technology enabler. And when you combine it with other enablers, such as, for example, artificial intelligence, you can create insight on demand, really powerful insight. And what hopefully you'll see from the images is that it's fundamentally changing what we can see and how we can interact in the desktop with that built environment. And that to me is the big change in the last 18 months, that we're really now enabling people to interact with the built environment and the natural environment for that matter to a much higher level of detail and do so much more on the desktop. Similarly, if you add in the ability to add in real-time data from smart devices, for example, stream it through ultra-fast broadband, 5G, store that data in the cloud and provide a hosted management service, and then deliver that back to users in an easy to use form. That is why geospatial data to me is suddenly exploding in interest to a lot of new users. And we've tagged this expression geospatial immigrants, which is stolen shamelessly from digital immigrants. So I'm a digital immigrant because I wasn't born into the technology, but I now work with it. We're seeing a lot of geospatial immigrants. They're not natural users of geospatial data, but they're waking up to the value it brings to their organization. What we get with solutions such as Skyline is the ability to really make that easy for both geospatial natives and particularly these geospatial immigrants to work with the data and interact easily with that data and get the most out of it. And that's what's really exciting to me now. What that means now is that organizations can share information and insight and business intelligence so much easier, both within their organizations and with their key stakeholders, and even with the general public if you're in a public facing environment. So we're seeing that collaborative environment really coming to life, and that's really exciting to us, and particularly as someone who's passionate about geospatial solutions, having been in the industry so long, I'm really excited about the direction the industry is going in. That's led us as Get Mapping to produce what we call a collaborative platform. So GSAS is very much about a collaborative space. It differs from other geospatial platforms in our eyes because the problem we see with most platforms is they tend to have a single data set at its heart and a single way of viewing that data, or a couple of ways of viewing that data, which is fine in one instance. But the challenge with that is I think it always means you're trying to shape the problem or the opportunity to fit the solution that you have. And we think that's the wrong way around. So all of our engagements now start with a conversation, start with a question around what is it you actually want to do? What is it, your opportunity or your challenge or your problem? Based on that, we can then identify what content you need. So the GSAS platform has a lot of content that is ours. We have our national imagery. We're now showcasing today the next generation of imagery for cities. But we also serve up third-party data. So if the right solution for you is a third-party solution, that's the right answer for you. If content isn't enough, we can also, of course, offer a bespoke survey service, be it from the air or the ground, to supplement it. So if the currency of the data or the location of the data is not quite right, then a bespoke survey can be added. It's typically a little bit more expensive, but it's about creating the right solution for you. The two combined mean we can start with the right data, and that's really important. I think when you start with the right data, your challenge, your project, your opportunity has a much better chance of success. The second part of it, which is where Skyline really comes in as a great solution, is how that data is hosted, managed, and served out to customers. So we have customers who are geospatial natives who want to take the data, work on it themselves. They have the infrastructure, they have the software to do that. But increasingly, the customers we're engaging with now just want the answers. They want either to interact with the data and visualize the data and play around with the data, or sometimes they actually just want the final answers. They want to know, where are all the swimming pools in England? And there aren't that many of them, but where are they? And geospatial data, we can now deliver the solution you want, whether it's the answers or the imagery or a combination of the two. And again, this is what's, I think, changing the environment, and what GSAS is about is giving you the right data delivered to you in the right way, whether that's a very simple viewer or a very high-end, powerful professional software solution that allows you to do a lot of analysis, or just the answers using our AI, using our machine learning algorithms to deliver up answers, and everything in between. So to us, this is about a collaborative space. It's a little bit cheesy, but you know, customers now are partners. But also, I'm sure there are people on this webinar today who are technology or solutions providers that we also want to be engaging with and having conversations, because there are so many different solutions we can now serve up with this data, and we're barely scratching the surface. So whether you're an end user, a supplier, or a solutions provider, all of those are good reasons for us to have a conversation. And what we want to get out today is the start of that conversation. So GSAS is more than just a single platform. It's a range of content, it's a range of bespoke survey solutions, and it's a range of ways of hosting, managing, streaming, and visualizing data. Which leads us on to specific content to Southwark, the reason we're here today. As Valerio said, it was flown with the IGI Pentacam and with a light map and LiDAR system. We were driving to 3 centimetre vertical and oblique data, and that's significant to us. That's the highest resolution we've ever done for a content program for city mapping. So we've done high resolution 2 to 3 centimetre bespoke surveys for a railway or for a road section, but to now start to deliver content as part of our content program, this is being driven by technology, the IGI technology, the ability to do it at this resolution cost effectively and scale up to a national program mapping our cities. This is the way that the market is going for us, and it's really exciting because it's opening up lots of new opportunities for people, and it's driven by the technology both at the capture end and downstream with companies like Skyline in the visualization space as well. And our job at Get Mapping is to bring together the right solutions for you as users. Just to showcase the data, this is an extract from our London Southwark national 12.5 centimetre data, and this data is used by a wide range of people. It's licensed through APGB to the public sector, so there's over 1,200 organisations use 12.5 centimetre imagery. Lots of commercial organisations, architects, surveyors, engineers, etc. use the data, and there's a lot of value in the data. But when you now put it alongside our 3 centimetre data, you can see why it's changing the way our customers are working, because fundamentally it's changing what you can see. It's really visualising the built environment to a much higher level of detail. Now you can see the pavement condition, the road condition, the road markings, all of the street furniture. So it is a step change for us, and we've seen that in the last 12 months in the conversations we're now having with our customers. And I've only got a few minutes, so I'll give a couple of examples of what we're doing. But what I really want to do is just spark in your mind and in your imagination what this data might help your organisations do, or help your solutions do and deliver. And let's start that conversation. It's important as well to recognise the big change now, I think, is you can not only work in 2D, but now in 3D as well. And I think I'm not going to show a lot in 3D because Ite is going to do that much better than me in Skyline. But what really struck me when we did a run through of this last week and seeing Ite's presentation is he's showing practical, tangible applications of the data in 3D. And I think until recently, to me, 3D data has mostly been used as a pretty visualization tool. That's changing now. What you used to do in 2D, you can now very easily do in 3D as well, and do better in 3D and do more in 3D. So I think in your minds, if you want to take away from today, one of the things to take away is definitely that 3D is now coming to the party, and think about how you could do things better and more efficiently in 3D instead of just in 2D. So just to finish up with a couple of quick examples, and as I say, the challenge we have at the moment is we can fill the Get Mapping boardroom table with post-it notes of opportunities and applications and things we can do with this data, and that's really exciting. But of course, I can't showcase all of that in about 2 minutes flat. So I'm just going to give you a couple of practical examples. As I say, again, what we want to do is start conversations. So if this in any way makes you think, I wonder if we could do this, we don't know what the answer is, but let's have the conversation. So in terms of road surfaces, you saw in the 12.5 centimetre that you can see the road markings, but now we're at 3 centimetres, super high resolution. You can also see the condition of the road markings. So we're now working with local authority partners and highways maintenance companies around identifying where there's a need for change. And again, this is where tools like artificial intelligence come in, because our algorithms can do that automatically. You can visualize it and map it up for yourselves, or you can let the algorithm do it for you and set the tolerances for yourselves and automatically identify an inventory of what needs fixing. It doesn't take a lot of leap of imagination to see you can also apply that to a whole range of street assets. So the whole street asset management space now is fundamentally changing because of the resolution of the data. So again, just in this snapshot, you can see a cycle parking zone up the top here. And of course, in London and some cities in the UK now, we're getting scooter parks as well coming online. You can see a series of wheelie bins, of refuse bins here. And also, of course, when you go into the 3D that Itay will show, you can see the access to those and how they're stored and how you can make the collection of that refuse much more efficient. You can see all of the street furniture, you can see the condition of the pavements, the condition of the road. Come on to the properties in a second separately, but there is just such a wealth of data now, and it really is enabling new users to do a lot more on the desktop. So we have customers now doing so much more on the desktop and so much less in the field. And that is so much more efficient for them, the amount of time and effort that's saving. And of course, with the pandemic, if it's taught us one thing, it's that it is possible to do a lot more from home than we ever dreamed. And it's really working for our customers. Anyone who is interacting with the built environment and managing assets in any form is benefiting from this high resolution data. So in a similar way, just as a quick example, using artificial intelligence, we can map all the street lights in a borough. So Southwark has over 20,000 street lights. We can map that using AI in under an hour to a very high level of accuracy. And of course, we can do that for a wide range of features. I'll just finish up quickly mentioning property, an example in the property space. So of course, this imagery is hugely relevant for everything from pre-build to construction, to management, to maintenance of properties and to refurbishment of properties. In this space, we have a client who manages a large portfolio of commercial properties. And the challenge they have is that it is very time consuming to do site visits, and they need to do site visits, whether they're looking at the facades or the roof of properties. And the roof actually creates a bigger challenge for them because it introduces a level of risk in terms of personnel. And unfortunately, over the last few years, there have been incidents and injuries from people working on the roof. It is inherently a little bit more dangerous. With this data now, they're able to reduce and significantly remove a lot of that site visit work and that risk, because they can see what they need to see in the imagery. So they can see here all of the solar panels, they can see all of the air conditioning ducts, all of the air conditioning units. In this example, they can also see a pile of rubble and old piping that a contractor's left behind, which in itself creates a risk for them. And with the storms we've had in the last few days as well, you'd worry about that sort of rubbish sitting around on the roof of your property and getting blown off onto unsuspecting passers-by below. So there's a huge risk mitigation, both in terms of personal safety and safety, general duty of safety to the public, that this data helps to reassure and to reinforce, as it were, for our users. So a lot of users now are using this data to replace or to significantly reduce the need for site visits. The other added advantage, of course, which you'll see in Itay's presentation in a second, is you can interact with this data in 3D, and you can actually do things that you can't do on a site visit. So unless you've got a rocket jetpack, you can't really hover 20 feet away from the building and have a look around the building. But of course you can in a digital model. With the level of detail now you've got, you can look at this, and taking the example of the rubbish, which was here in the previous image, it would actually probably cascade it with the prevailing wind down onto the building below. So it's not necessarily going to do human damage, but it's probably going to do property damage. All of that comes from being able to assess things in both 2D and 3D now, and see the whole environment around things. I'll wrap it up at that point and let Itay do some great demonstrations in 3D on the data. What I just wanted to reinforce, I think 3 takeaways for me from today for you would be the fact that geospatial is now a key technology enabler. So have a think about how that sits in your digital transformation strategy, and we're more than happy to help you have that conversation. This resolution is game changing in what you can do, and we're seeing that with our customers now. So it is a fundamental step change in what's possible in the desktop, in the digitizing the built environment. And don't discount 3D. If you know, 3D is coming to the party now, and it can do a lot, and Itay is going to showcase that. Love to have conversations with you. So if anyone wants to reach out to either myself or my colleague Helen, who's our business development manager for Europe, we'd love to start a conversation, whether you are a supplier, whether you're a user of data, or whether you have some great new solutions coming to market that this data could really support. All of those we'd love to start. I'll just work out how to unshare my screen and pass it back over to you, Valerio.
No worries, Dave. I will do it because I will start the presentation from Itay. So thanks a lot for this presentation. It's really nice for me. It's really sparking like new ideas, and it's clearly see also a nice representation of the maturity of the market. The geospatial market is growing, and it's really to the status where we really not just talking about 3D, but really seeing like real life application. So Itay, I will start to share the presentation for you. I have also some information. We're not sure if the QA is actually available. So in case you would like to make some questions, please get in touch with us. There will be a slide at the end of the session with all the emails. If you can also try to write in the chat, because we were checking with Nazira, we are not sure that the QA somehow is popping up. So please try to engage with us, try to use the chat. If it's not working, we are sorry about this, and you can just write an email. We will get back to you later on. Okay, so I think this Itay is going to be your first slide. So
okay, well, thank you, Valerio and Philippe and Dave. So I'll give a quick overview of Skyline and some of the things that we're going to be demonstrating in Skyline's technology. Skyline is a software that provides 2D and 3D solutions and software, combining any sort of 2D and 3D geospatial content. Our headquarters are in the US. We have international companies, providers, distributors all over the world, including in the UK. Dave Loescher manages our UK office, and you'll have his contact information, as well as in Europe, Australia. So we work with different industries, military, defense, urban planning, design, survey, and mapping. So we'll go through some of the uses that the 2D and 3D content that we produce can be utilized. Next slide. So the Skyline architecture combines different components. The main ones are PhotoMesh, which we will look over, which creates the 3D content. PhotoMesh combines imagery, LiDAR, different sources of data from different platforms to produce 3D and 2D layers. Terra Explorer is our visualization and analytics engine. Allows you to visualize the data, to display it, to share it, to analyze on it, simulate, measure. And then Skyline Globe allows you to host and stream the data through the internet to different platforms, the desktop platform. We have a Terra Explorer for web platform, mobile. So it allows you to share large 3D content and the analytics, measurements, vector layers, point clouds, anything you'd like. Next. So the PhotoMesh portion is the one that combines images, LiDAR, street view, aircraft, drone. We'll focus on the IGI aircraft with the LiDAR, the IGI Digicam, or Penta Digicam.
Correct.
And we can go to the next slide. So the highlights for PhotoMesh, it creates really high quality 3D models and 2D orthos and point clouds, DSMs in large scale. So we can scale to extremely large data sets, hundreds of thousands plus projects. We have a proprietary edge detection and linear feature extraction. So we extract automated break lines essentially, and 3D vectors. And we create 3D models from the combination of the point clouds, the vectors, the surface models, and the textures. And we use a scalable architecture which allows to run on multiple computers, up to hundreds of computers in parallel, either in a cloud infrastructure or a local one. And it could be utilized with any sort of computer. Next. So the inputs for PhotoMesh, we support high-end, low-end drone. We work very well with the high-end systems from IGI, and we've collaborated with them to optimize the results from the software. And with the combination of the LiDAR, we support additional bands, so 3-band, 4-band, up to 12 bands in the output and the input. And the output, we output 3D mesh models. We have our own format, the Skyline 3DML. We also support Cesium 3D tiles or SLPK, 3MX, so really a lot of different formats that the market can ingest. We export point clouds in LAS and true orthos, DSM and DTM. Next slide. So we do have an upcoming release of PhotoMesh 7.8. Some of the enhancements are improved ortho quality. So we've modified the ortho algorithm to produce better edges, better texture blending between images and texture selection. We've added close range capability, so combining really close range terrestrial data or a very low altitude drone combined with aerial or mobile mapping. So being able to get the combination of large coverage and really high resolution. A more robust aerial triangulation engine in order to be able to combine different perspectives and different resolutions. LiDAR integration, we've improved that as well on top of the existing capability. And our PhotoMesh automation, which allows you to automatically process data on the cloud or locally. So we've enhanced some of the automation and scaling, made it more efficient. And improved performance up to 15%. So the software is just generally faster. Next. Terra Explorer Desktop, which we'll go over, that's the visualization. So when you produce data from PhotoMesh in 3D, you can simulate, you can measure on top, you could add different geospatial layers and integrate them together. Next. And then we'll see also how you could integrate those different layers and how it combines with the rest of the Skyline architecture. Next. And also the Terra Explorer for web, we won't go into too much detail, though that's also the ability to disseminate the data using a web browser. So any project that gets hosted on the globe can then be shared with a link and can be managed for accessibility and permissions. Next. So right now we'll jump into the London project from Get Mapping. So quickly we'll look at some of the results. The data was 6,548 images. We look at data in terms of gigapixels. That's sort of the unit that allows us to estimate how much processing it's actually going to take. So it's pretty correlated to how much gigapixels there are in the project. That's usually how much time the process is going to take. This software, this process specifically ran on about 120 machines and it ran relatively fast. under 6 hours, and we see the median error is 1/4 of a pixel. And we've used some control points from the LiDAR, which we'll go over in the demo. The total accuracy is extremely well, under 2 centimeters in the vertical. So very well co-registration between the imagery and the LiDAR. Next, I'll go into the demo. So this shows, for example, the type point, automated type point extraction on the project, and we can see both the density and the coverage, the complete coverage of the type points in the project, which connect the nadir, the obliques, every single perspective, all in a single bundle adjustment performance. So I'll jump into my screen right now, and we can start to have a look a little bit in the PhotoMesh project, and then we'll look at the Terra Explorer applications that were produced with it.
Yeah, go ahead, Itai.
No problem. Okay, is my screen okay?
Yes. Yeah.
Oh, okay, excellent. All right, so we're looking here now at the PhotoMesh project. Over here we can see the 5 images colored by collection. So we have the forward, the back, the right, and the left, and the nadir. This is one of the images projected onto the terrain. And over here in these blue bounding box, we can also see the LiDAR. So for example, if I show the point cloud, we can see all the inputs, the imagery, the LiDAR input. The imagery was imported with the initial exterior orientation, XYZ omega phi kappa, and the basic camera model. Now we can also project this image onto the LiDAR, and we can see the image being projected onto the LiDAR points already very nicely. Okay, so this gives us a sense of one image being projected onto the LiDAR points. Now we can also look at this image and see all the type points that were extracted on the single oblique image. And all of the green points are multiple matches. So you see, if I click here, by the way, on one of the matches, I could also see the images that participated in the type point. Okay, and we could see there's a lot of different combinations. So some of them could include a combination of nadir and oblique. This is an oblique image, this is a nadir image. Some of them are type points on facades, so they're most likely to include only oblique images. But there's a very large variety of combinations, perspectives, type points, which enable the AT to correlate everything in a very low error, very high geometric precision. Okay, now one of these type points we can see over here, type point that was used with the LiDAR, and it's over here, the corner of this sidewalk or this road marking. And we can look at the type point, the control point editor allows us to pick points or import points from a survey and then measure them in the images, sample them. And we can see here's the feature. Okay. And the data is now extremely co-registered, extremely accurate to one another. So let's clear out some of the data that we're viewing in here. And now, once the AT is complete and we looked at the report, the project splits everything up into reconstruction tiles. And we can look in those reconstruction tiles, for example, the point cloud from the photos. So this is the image-based correlation, and 100% of it will be from the images. And then we can also look at the images at the point cloud from the LiDAR. Okay, so this is the image-based point cloud. And I'll turn on the LiDAR-based point cloud together. Okay, now if I turn off the photos and we look at it, here we go. Let me turn on the depth perception. Okay, so we can see that there might be some gaps in the LiDAR, that over here this facade maybe isn't as dense as we'd like it to be, or this side of the house. The LiDAR is extremely dense and detailed, and we can see it extracts information underneath vegetation very well. When we add in the image-based point cloud, you can see it fills in a lot of these gaps. And at the end, we produce a merged point cloud, which is actually filters out redundant points and prioritizes LiDAR points so that it can clean up a little bit noise from the image points, but this is the merged point cloud. So at this point, it's both the image point cloud and the LiDAR point cloud. This is the model, the surface model, and then that model gets textured. Okay.
Itai, I have a quick question.
Yes.
Was this now real processing, or is this just that you have different views and the processing has been
it's
all done in
views.
the back?
Yeah, this has
Okay.
already been processed. Yeah. And I'm just showing this to show the nice separation here between the tree and the building given the LiDAR. And on this specific tile, how it works is it also, oh, that's not the ortho one. It produces the ortho on a tile basis, and then all the texture models on a tile basis, and then it combines everything, see, into a single complete layer. So at this point, the project is complete, and it has all of the outputs that were exported for it, the ortho, DSM, OBJ, meshes, so really any sort of output that you would like to get out of the software. And we'll jump into the Terra Explorer portion. Second, here we go. So now when we're done with the project in PhotoMesh, we can open it inside Terra Explorer. This is the Terra Explorer viewer. And you can see it has a lot of additional information. You can add boundaries, names, cities, locations, GIS layers. Right now we're looking at the mesh. This project also contains the true ortho that was produced. And the LiDAR, just a second. So here's the LiDAR, colorized in a nice way. And another advantage of Terra Explorer, can also display point clouds and very large scale. Okay, so we'll start a little bit to discuss what's the difference between the 3D product and the 2D product, and how they provide different information, why they're both necessary. So for example, this building is a nice 3D model of a building. When we look at it in the ortho, we can see the supposed footprint, the building being rectified down to the ground, or orthogonally. And then at this point, if we look at the building footprint, it would look something like this. Okay, just to give you an idea, this is a true ortho, so you're not going to see any building lean, and everything is perfectly vertical. The difference between this and, let's say, a mosaic is this. So you see an ortho mosaic, rectifies the image on a per image basis and not on a per pixel basis. So tall buildings can have displacement, and you can see over here it actually covers the road, so you lose data, and this is not the true representation of any of the building footprints. So first of all, this is a true ortho and very high quality, useful product. It's actually an engineering grade product. Everything in 2D has the correct scale, the correct relative relationship. If we look at this building, though, in the 3D, we can see this is the footprint on the ground, okay? Which obviously doesn't represent the actual footprint of the building. It more represents this footprint at the top of the building. Or not at the top, sorry, at the widest point of the building. What is the actual footprint is this one. Okay. Now, if we look at this on the ortho, it's very hard to see the footprint, obviously the actual footprint on the ortho or in a 2D view. So this is where 3D becomes very critical. Also in the ability to see all this information in the street on the true ortho. And in the 3D, you also start to get more than just information from a 2D view. So you're saying some of this information is still visible from the top. This is visible from underneath, but we can also look, let's say, at an example like this. So let's say we have GIS data, and this data is the Ordnance Survey Master Map topography. First of all, we can see how accurate it is and how well it lines up with the 3D data. It's pretty much on the pixel. Second of all, you can see that if you're looking at vector data on 3D, it starts to disappear or get hidden behind trees. We have the option to do show through. So actually, when you zoom in, you can see through the buildings and you can see all of the vector data to enable it. And over here, for example, this is very useful to see this in the 3D. You can see this path going actually underneath the trees, and with the LiDAR data, it actually extracts that information. So you get the full benefit of being able to see underneath the sidewalk and understand what all these markings mean. It's always an option to look at it on top of an ortho, which would look like this. But you can see this doesn't have the same level of information that you'd be able to extract in the 3D or tree coverage. Okay, so this is one aspect of it. And over here, by the way, you can see it has both footprints, interestingly. It has the correct one, the inner one, and it has the total at the widest point footprint. And they both line up perfectly. The other things that we can integrate in, so when you have a 3D mesh, you can also colorize it. I'll turn off the topographic layers for a second. So see, for example, you can incorporate building footprint information or cadastral information. I can click on it and get its attributes and display its labels. So you're looking at the 3D in a very informative way. Not just in a visual way. The other aspect of it is we can also incorporate road layers, and this could be viewed both on the 2D or on the 3D. And this can also have the show-through capability. Okay, so these are some of the GIS integrations and using 2D and 3D, the benefits of having either one. Another concept of it is using underground. So, first of all, measuring in 3D doesn't account to just area or footprints. We can also look at, let's say, this area over here. So this was actually an article that came out about a certain viewing platform. I'm sure a lot of people in England are familiar with this. And over here it states that it's about 34 meters away from people's buildings or people's living rooms. But when we actually look at it and the 3D, we can see that it depends really on which apartment you're looking at, and it could be even as short as 24 meters or 32 meters or 43 meters. So these are different 3D measurements, and it would be very difficult to do any sort of measurements or prove it looking at an ortho, where everything is just a single measurement to a 2D representation of the rooftop. So this is another example of using 3D for accurate measurement in critical situations. Practical applications. And now if we look at the underground data, so we can also see how it interacts along with the city, and this allows us to also navigate underground. Now, some of the applications for this could be if we're looking, let's say, at a construction site. over here. First of all, we could see it represents the depth of the construction site, and this is something that we can measure. We can measure the volume, the full fill, and we can also represent what it looked like before. We can modify the mesh on the fly. So if we look at the representation of what this building would look like, and if we look at the location that some of the pipes pass close to the area, right here, we can see how close it could get, and we can also measure it very accurately in all the axes. So we can measure about 5 meters away, but we can also measure the distance to the surface of the corner. So really any sort of 3D measurement that you want to do inside the underground environment. You can see about 8.5 meters below surface and about 5 meters away from the pipe.
Yeah, that's really amazing.
And the other thing we'll jump to real quick is the, so now let's say we have a building, or we have a CAD model of a building that wants to be designed, or we have a very high quality representation of a building model. We can jump to the location. Second, here we go. Like the Shakespeare Globe. So this is the dynamic mesh, the interactive mesh that we're playing with, and we can edit it on the fly. So we can flatten this mesh and actually place a model of the Shakespeare Globe on top, and we can even jump inside and see what it looks like. And from the outside, whenever you have more complete BIM models or internal information, one of the things that you can utilize it with is the cross-section tool. So let's say if you want to view it floor by floor, I can place this on top and make it a little bit bigger, change the direction, and I can move through the building, see the different levels. So you can integrate additional BIM models, CAD models, integrate it seamlessly in with the mesh and have it in one single complete environment. You can see how well it interacts with it. And then if we look at some of the other underground capabilities, see, we could turn on underground. If you have obviously the tube or the London Underground, you can integrate in, you can put in different models of it, models of the trains. So pretty nice model of that. And the last thing is that when you have everything nicely configured and you want to visualize it, you can always just create a presentation. And then, like Valerio was showing, you can have the different layers turned off or on. You can jump through automatically, the video we're showing. So everything can be put together into a nice presentation or can be shared in that presentation. And while it's doing it, you could turn off layers. And that's about it.
Great, it's really looking awesome.
Yeah.
Also lots of potential, so I think this is really great. So even that we have seen possibilities with high imagery data, and then also in 2D and also in 3D, this is really amazing. But I think unfortunately we could get the Q&A session back, so this is really something that we have to apologize. So this is not what it was intended to be. So this is just half the story, I think, for a webinar. So normally it's also that you can interact with us. So I can just encourage you, please write all your questions directly to us. And if there is enough potential, I would say, if there are enough questions, then maybe also Dave and Itai, we can have maybe a second session, maybe just a question and answer session, so that we can just go also into this direction, because now also time is running up.
Yeah, I will be sharing just our email address, so it's just in case, like, you can get in touch with us. Thanks a lot, Ida. It was an amazing demonstration. Also, is really showing the abilities that we have from 2D to 3D, but also in application, which is exactly what Dave was also mentioning. So producing high quality 3D data and products, and then also work with this data, not just for visualization, but also real 3D GIS application. So we hope that you've been enjoying this session. We will go through, you have our email address, so feel free to get in touch with us directly for any question. Would be really nice. And we will be also open to maybe to have another session, just 15 minutes to go through QA, or we will get just back to you. So thanks a lot for joining us and to stay with us. I can see that we have exactly the same number of people from the beginning until the very end. It's really appreciated. Thanks also for joining, Dave and Itai. It's a real pleasure. And I started the webinar meaning and saying about collaboration. And we really see that this is really the next level for geospatial collaboration with our clients. A technology partner from Skyline is really, really nice. And please engage with us also. If there is anything else that you would like to see in the next session, just ask me, Philip. And just write to us, and we can also prepare more dedicated session about what you would like to see, or maybe some challenges that you have. And this can also be something that we can have in mind for the next webinars. So again, thanks a lot from my side, and stay in touch.
Thanks, everyone. Thanks for having us.
Appreciate your time.
Thank you. Have a great day.